All right, students, welcome to useful trig identities, trig integrals. It's nice over here in London, raining and cold as usual, just like Seattle. But anyway, we're looking at some useful trig identities, the Pythagorean, and it's trig integrals, and it's nice to have some of those trig identities refreshed back up to the top of your memory here. The Pythagorean identity, sine squared x plus cosine squared x equals 1. Tangent squared x plus 1 equals secant squared x, and 1 plus cotangent squared x equals secant squared x. Those are really nice, useful transformations that are helpful when you're doing these trig identities. Also, it's nice to have these double angle identities that allow us to change the degree of things from a second degree to a first degree. Cosine squared x equals 1/2 times the quantity 1 plus cosine of 2x. Sine squared x equals 1/2 times the quantity 1 minus cosine of 2x. And a lot of times we're going to end up doing the chain rule, and so, or not the chain rule, but the doing a substitution. And so it's really nice when you've got that du sort of thing to remember what those du's were and kind of think ahead of what those are going to be. And the derivative of sine, of course, is cosine. The derivative of cosine is minus sine. The derivative of tangent squared, or tangent, is secant squared x. And the derivative of secant squared is secant x times the tangent of x. So let's do an example. Let's find the antiderivative of sine to the 8th of x times cosine cubed x with respect to x. And so I've got an odd power of cosine. So what I'm going to do is I'm going to take two of those cosines. I'm thinking I've got to do a substitution. I'm looking at the sine of x raised to the 8th power. And I've got the cosine of cubed x. I'm going to take that as a cosine squared x times the cosine of x dx. And I'm pulling off that one cosine of x because I know the derivative of sine is going to be cosine. And I'm going to probably end up using that substitution in there where I'm going to need a cosine as part of that. So let's use the trig identity. That's the sine of x to the 8th. Replace cosine squared with 1 minus sine squared x times the cosine of x dx. And now we can do a substitution where u is equal to the sine of x, and then du is equal to this cosine of x dx. So this second part here of our integral is just going to become a u. And so our integral becomes the antiderivative of u to the 8th times a 1 minus u squared du. And to solve that integral, we're going to distribute the 8 through. I want to find the antiderivative of u to the 8th minus u to the 10th du. And that's a nice simple polynomial. We just add 1 to the exponent, divide by the new exponent. So u to the 9th over 9 minus u to the 11th over 11 plus c. And of course we always have to go back to what we started. We have to undo that substitution. And so let's go back. We know u is equal to sine of x. So I'm going to have 1/9 of sine of x raised to the 9th power minus 1/11 times the sine of x raised to the 11th power plus c. And that will be our antiderivative. All right. I think we got time here. Let's go ahead and do another one. What if I have the antiderivative of sine to the 4th of x dx? And now I don't have a cosine there to work with, but what I might start with this one is doing that power reduction formula. That would be the same as the sine of x squared, sine squared x squared. If you square a square, you're going to get to the 4th power there. And then I can replace that with the 1/2 times 1 minus cosine of 2x, but that whole quantity is being squared. And so my integral becomes 1/4 times 1 minus, foiling out this 1 minus cosine of 2x is going to give 1 minus 2 cosine of 2x minus or plus cosine squared of 2x dx. And so I've got the antiderivative of 1/4 minus, see, the 1/4 times the 2 is going to give me 1/2, the antiderivative of 1/2 cosine 2x dx plus the antiderivative of cosine squared 2x dx. Alright, we shouldn't have any sort of problem on the first two antiderivatives, but the last one is still going to give us a little bit of a problem. So I'm going to use that double angle formula again on that one. Let's go ahead and do these as we go. So the antiderivative of 1/4 is just 1/4 x. The antiderivative of 1/2 cosine, well, the antiderivative of cosine is sine. Yeah, derivative of sine is cosine. So the antiderivative of cosine is just sine. So I'm going to have 1/2 times the sine of 2x. But I've got kind of a chain rule going on there. I've got an inner function in there. Its derivative is 2. I'd multiply by that 2 when I'm taking the derivatives. I'm going to divide by that 2 taking the antiderivative because I'm doing the opposite sort of thing. And with this cosine squared, I'm going to replace that with a 1/2. Whoops, I forgot the 1/4. I still have that 1/4. I forgot to distribute that 1/4 all the way to the end there. So I'm going to have 1/4 times the quantity 1/2 of 1 plus cosine of twice the angle, and twice the angle, my original angle was 2x, so this is going to become 4x in there. Twice the angle will become 4x instead of 2x. So let me scroll up here, give me a little bit more room. I've got the 1/4 x minus 1/4 sine of 2x plus 1/8 the antiderivative of 1 plus cosine of 4x dx. Alright, and the antiderivative of 1 is just going to give me x. So 1/4 x minus 1/4 sine of 2x plus 1/8 times the antiderivative of 1 is just going to give me x. And the antiderivative of cosine of 4x is going to be sine of 4x. But if we were to take the derivative of sine of 4x, it's going to kick in a multiplying by a 4. So I need to divide by 4 to undo that. And then plus c at the end. And so that is it. We can maybe do some simplification in there, but there is our antiderivative. 1/4 x minus 1/4 sine of 2x plus 1/8 x plus 1/32 sine of 4x, and then plus that c there at the very end. Alright, there's a couple of examples. I think that should maybe get you started, and maybe I'll do another one here. I think I'll do one more for you. Yeah, I got time to do it here. We'll just do it in this one. So here's another example. Let's do one with the secant. Let's do the antiderivative of secant to the 4th x tangent to the 6th of x dx. Alright, secant to the 4th tangent to the 6th. And again, I'm going to think, well, something's going to be a u, and I have to take the derivative of that. So if I do u is equal to secant of x, then du would equal secant x times the tangent of x. And if I'm looking for finding a secant x tangent of x in here, I end up with a secant to the 3rd power and a tangent to the 5th power. And I can't really, I'm kind of stuck with that. So that's not such a good choice. It's better to do u equals, in this case, u equals tangent of x, because du is going to be secant squared x dx. And so what I want to do is I want to split up this secant to the 4th I want to call it a secant squared of x tangent to the sixth of x times another secant squared. Why did I write sine? It must be the jet lag. I'm going to blame it on the jet lag. Secant squared x dx. So when I'm doing my u substitution, the secant squared x dx is going to become my du when I go to do my substitution. But I just need to substitute for tangent, so I need to get rid of the secant squared. But I have a trig identity that tells us that secant squared, in terms of tangent squared, if we scroll back up to the top, we had that secant squared is equal to tangent squared plus 1. So I can come back down here and replace this first secant squared with a tangent squared x plus 1 multiplied by tangent of x raised to the sixth power times secant squared x dx. And again, I'm keeping that secant squared x dx out because when I go do my substitution, u equals tangent of x, I need secant squared x dx to be my du. So I'll have the antiderivative of u squared plus 1 times u to the sixth times du in there. And then to find that antiderivative, just multiply through. Nice and easy. I get u to the eighth plus u to the sixth du. And then the antiderivative would become u to the ninth over 9 plus u to the seventh over 7 plus c. But I didn't start with u, I started with x. So I want something with x in it. And my u, again, was tangent of x. So my answer will be tangent of x raised to the ninth power divided by 9 plus the tangent of x raised to the seventh power divided by 7 plus c. Alright, there you go. Be sure to note there's an in-class assignment that I'd like you to do on these trig integrals. There are 2 problems that are listed in on that in-class assignment section of your textbook, and so you should be doing those approximately on Wednesday is when those would normally be scheduled to be done. So hopefully you're keeping up with things. Alright, have a good night, or good day, or whatever time of day it is that you're looking at this.